thank you very much for being here today and for surviving till the end of the conference. I hope you won't die during my talk and you will stay awake. I want to start with a public service announcement. We don't serve beer here. So in case any of you thought that it was the networking beer, that's actually another room. I'm sorry for that. It's also a very hard position for me today because I'm the only thing between you and your beers, because beers will be at the end of this talk. So I will try to stay as focused as possible, and I will try to not take too much time, otherwise you won't be able to get your beer. Okay, awesome. So we're not going to talk about beers today, but we're going to talk about HTTPS. Specifically, our agenda today is divided into 4 different areas. The first one, we're going to have a quick recap of what is HTTPS. Probably a lot of you already know about that, but if you don't, that's going to be a very confusing talk. So I want to make sure that we are more or less on the same track. We're going to talk about obtaining an SSL certificate, deploying an SSL certificate, and serving HTTPS. If you don't really know what's an SSL certificate, don't worry, we're going to go through that. And we're going to start from the beginning about the protocol till the end when you hopefully deploy HTTPS on your servers. Because HTTPS is also about trust, before going into the details, I want to make sure that you trust what I'm saying. Sometimes I say bullshit, but hopefully not today. So I'm going to introduce myself so that you can at least try to trust what I'm saying. My name is Simone. You can find me online with this nickname. It's Webpost. It's more or less everywhere, from GitHub to Twitter. I work for a company which is called DNSimple. The company provides domain services, specifically DNS hosting, SSL certificates, and a lot of services connected to domain registration. We are ICANN accredited. And we're a kind of small company, so I wouldn't be surprised if most of you don't heard about us. But let me ask you a question. How many of you used or visited the GitHub homepage? Can you please raise your hand? Okay, keep your hand raised, please, so that you stay awake. It's also a way for you to stay awake. Then how many of you also use maybe Travis? Have you heard about Travis CI? Okay. How many of you have ever tried, I don't see the hands, come on guys, are you, okay. How many of you have tried the GitHub editor called Atom? Awesome, so I want to thank all of you because you actually used our services, because we provide DNS and hosting for all these brilliant services plus a lot of other products. So GitHub is using us, Travis is using us, Git is using us, and Atom is using us. The good part is that if you didn't notice about us, is because everything worked fine. So, I mean, the fact that you probably don't know us is also a very good thing. Let's start then talking about HTTPS. That's the first section of this talk. So the first question is, what is HTTPS? How many of you ever heard about HTTPS? Okay, good. How many of you deployed an HTTPS application? Okay. How many of you actually understood what it did? Okay, so very few of you can come here and make the talk for me. So what you have been told at university or like from coworkers, whenever you don't know something, the first thing to do is, well, let's go to Wikipedia. So let's see what's the Wikipedia definition for HTTPS. HTTPS, also called HTTP over TLS, HTTP over SSL, HTTP secure, is a protocol for blah, 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 blah. Not really very friendly. So let's retry. What is HTTPS? HTTPS is essentially, okay, sorry, I inverted. It's essentially HTTP over a secure connection, okay? What does it mean in practice? In practice, it means that HTTPS is HTTP, so the HTTP protocol you know, over a secure connection, encrypted connection. And the protocol that make your connection secure is called TLS. In the past, it was called SSL. I'm going to quickly discuss that later on. But for the sake of my presentation, I will keep referring to TLS because that's the right term. SSL is the very old and legacy protocol. Now, generally, you use the word SSL to reference the idea of the protocol, the idea like SSL certificate, we're going to see. But when you talk about specifically the secure protocol is TLS. Okay, but what if I want to explain that to my mother who has no idea about the difference between a computer and a microwave? Okay, so this definition is not really interesting. Let's try something different. HTTPS is essentially how websites securely exchange information today. Okay, that's probably the most simple explanation that we can provide. And that's actually the main reason why most of the website goes to HTTPS today. Not the only one, and we'll see about that. In fact, HTTPS provides two different components. A secure connection is based on encryption and authentication. So encryption is the process of encoding messages in a way that two entities can talk to each other without having someone else in the middle being able to understand what they are doing. Okay, so it's the process of encrypting information in a way that other people, unless the receiver, can understand what we are talking about. Authentication, instead, is the process of determining whether you are talking to someone who's claiming to be. Okay, so I want to make sure when I talk with my bank that the website is actually the website of my bank. I don't really care just if my bank the connection is encrypted, because I can even send my private credit card information to an encrypted scammer website. Okay, but that's not really good. Now, encryption is generally the most simple part. Wait, hold on. I'm not saying that encryption is simple, but in the context of HTTPS, encryption is the easy part, because encryption is made by very well-defined primitives and procedures that are normally widely implemented by your web servers and your clients, like Google Chrome or browser. So you don't really need to deal with that. Authentication is where things start to get clunky and complicated. Let's have a quick look about these two components. The first one is encryption. So hold on a second. Are you telling me that HTTP is not encrypted? Well, I'm sorry, but unfortunately, HTTP is not encrypted. And in fact, unfortunately, my slides were 16:9, so they are a little bit shrinked on the 4:3 screens. So you can't really see, but my slides will be online, so you will be able to see the screenshot. But what you can see here is a HTTP connection. Specifically, this is a Wireshark window where you can sniff an HTTP connection, so you can see the packets, the network packets going in and out. And this is an HTTP request, and that's an HTTP response. You can't really see that, but here you will see the plain text request as it was performed to your server. So you can see like get blah, 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 what it is. And in the response, you can see the plain HTTP content in the network. Okay, so if someone stays in the middle between you and the website you are connecting to, they can see whatever you are doing. And it's not really uncommon. Any service you use, starting from your internet service provider, Telecom, Fastweb, or whoever, will be in the middle of your connection. So they will have the ability to see whatever you do on the internet. If you compare the HTTP request with an HTTPS request, you will see that the same specific connection is encrypted. Now, both of them looks encrypted to you from the end of the room, but in this side, you will see that essentially there's no way to detect the information. It's just binary data. And unless you have the keywords to decrypt the information, you won't be able to understand what's going on in the middle of the connection. So what you're doing is essentially secure. Now, it's also important to understand that not just the content of the HTTP connection is unencrypted, but even the headers. So it means that when you are logged into a website and you perform a request and you pass your, I don't know, password or your session token, if you're using an HTTP connection, the token would be completely unencrypted, which means anybody can get the token and use the same token on their computer and essentially be authenticated as you. Okay, so that's a major, major issue. So here is encryption. Authentication is slightly different. So as you can see, authentication here is generally visible by and explained by the browser by a lock here. And so this is a secure web page. You can check the information about the entity and the authentication behind the connection by clicking on the lock, for example, the padlock, for example, on Google Chrome. And that will open a window that says certificate information. And if you click on that, you will see who is specifically the website you are connecting to. Now, authentication is provided by third parties, and we're going to talk about that. They are called certification authorities. So we have trusted parties that will verify your identity and will essentially grant you a kind of flag. And that flag is the SSL certificate that we'll see in a second. So the way you can see in your browser that the connection is trusted is by looking at how the browser behaves during the connection. If you see like a green here padlock, that means that the connection is trusted. And you can see who is the authority that is pretending your connection to be trusted. Now, if you look at that very untrusted connection, this is, for example, an encrypted connection, which means the traffic is still encoded. So potentially, people in the middle won't be able to understand what's going on in the network, but you don't know if you're talking with the right person. So you don't really know if you're talking with your bank or if you're securely talking with someone who is pretending to be your bank. And as you can see, the browser will try to tell you that your connection is not encrypted by giving you several different signs. One of them is a warning, and then there's also a padlock with an X in the URL. Probably some of you already encountered these kind of pages, maybe connecting to like Plesk panels and things like that. So as you can see, you can detect the information about the certificate here. You will see that, again, you won't be able to see that in the screen right now, but here the browser will tell you that the connection is encrypted, so it's actually secure, but you have no idea who are you talking with, okay? Now, there are different ways the browser can tell you your connection is authenticated, and it's reflected on the different type of certificates that I'm going to explain later on during the presentation. The first one is no encryption at all and no trustness at all. And as you can see, there's no green stuff here, no padlock. So this is a completely unsecure and encrypted connection. Then we have some cases. The green padlock means that the connection is encrypted, but it doesn't really tell you who is the company behind that. That's one kind of certificate. It's the one that just validates the domain you are connecting to. And then you have another kind of trustness, which is the ultimate trustness. As you can see, it's visible by a name, a green name, along with the padlock. And that means that the certification authority here went through an extensive authentication to make sure that not just you are talking with someone who is pretending to be that specific domain, but also who is pretending to be that specific company. Now, something that's important to keep in mind, and I will stress you later during the presentation, is that these two certificates are essentially providing the same level of security. They just provide different level of trustness. So I mentioned the word SSL certificate twice or multiple times during the presentation so far. I'm not going to talk about that right now. There will be some slides later on. But what I want to start to mention is that both authentication and encryption are connected to the notion of an SSL certificate. An SSL certificate is essentially a box when you store a bunch of different settings, and that specific piece of data will be carried over the connection and will be shared between the browser, or whoever it will be, the client, and the server, and that will be essentially the way the browser and the client will, the client and the server will decide how to talk to each other. I just want to make sure that you are aware by the fact that the SSL certificate exists, and it's a kind of global collection of settings. It's a shell for a bunch of different things that we're going to talk about in a few seconds. I'm still talking about how the protocol works in general. To relax your mind a little bit, because I didn't warn you, but this is a kind of technical talk, let's have a quick look at why HTTPS. So the question could be, why should I serve my website, even my personal website, through HTTPS? I don't really get any credit card information, so why should I use HTTPS? Well, there are several different reasons. The first one is, of course, security. The next one, and I'm going to quickly go through them, the next one is a ranking factor. So, well, of course, let's talk about security first. Security is, of course, as we said, encryption, so people in the middle won't be able to understand what's going on in the connection. Now, ranking factor, I don't know if you know that, but about 3 years ago, Google decided that in the near future, and we're talking about 3 years ago, websites using HTTPS will be preferred over simple HTTP connection, no matter which kind of website you serve, which means that for search engine optimization purposes, in order to be more visible in the search engine results, if you do provide your website through an HTTPS connection, that would be preferred. HTTP2, I don't know if you know about that, but after a very long time, we have a new version of the HTTP protocol, which is called HTTP2. Now, HTTP2 in the specification doesn't explicitly require HTTPS, but all the browsers decided that they won't support HTTP2 over a simple HTTP connection. So essentially, you are forced to use HTTPS if you want to use the new version of the protocol. HTML5 features. Maybe some of you use some of the what they are called powerful HTML5 features, like the geolocalization, like access to the SQL database provided by the browser, and so on. Now, in the near future, you won't be able to use those features anymore unless your connection is an HTTPS connection. Chrome geolocation. Very soon, you won't be able to get any information about the geolocation of the client from Chrome unless the connection is HTTPS. So if you're serving a website that wants to know, I don't know, where the user is to provide the closest restaurant, you won't be able to do that, even if you don't collect any information, unless you serve the website through HTTPS. And first of all, and lastly, Firefox will deny will essentially forbid the use of posts in the HTTP forms, like standard login forms, unless the connection is HTTPS. So we're going through, and I'm going to talk about all of these details in the slides. I will fastly go through all of them. You can, if you download the slide, you will see the links where I have a reference to any of these information. So I just skimmed through them. But the thing is that we're essentially in an area where very soon, in the next years, you won't be able to use essentially any of the extra powerful HTTP features unless you serve your connection through an HTTPS secure connection. So it's not just about security. Okay, now it's the time to quickly have a look at what is an SSL certificate. A certificate is a digital document, more or less like a PDF and so on. It's a digital document that contains a public key, some information about the entity associated with the certificate, as I said before, the validation, and a digital signature of the issuer of the certificate. It's a lot of things. We're going to explore them later on. This is a picture of an SSL certificate. You can see there's a version of the certificate, there's a serial number, which is the unique representation of the certificate. There's the issuer, which is the entity who decided to issue that specific certificate, that is the trusted authority. There's a subject, which is the domain the certificate applies to. Okay, so every certificate has a range of domain it applies to. There's a public key. I'm going to quickly explain that later on. And there's a validity. A certificate doesn't live forever. Okay, so generally they have a 1-year validity, and after that you have to request a new certificate again. And there's a bunch of extensions that I will not handle. But the key things you have to keep in mind is that this container is essentially where you store all the configuration of your connection, and you will pass that along in the HTTPS connection. As I said, there are different types of certificate. There is a single name that it's valid only for example.com. So if you try to use that certificate for another website, that will say, hey, that connection is not trusted. Okay. There's a wildcard that works for a specific level, and there's a SAN that works for like several different domains within the same certificate. Why is this relevant? Because all of these, as of today, have several different costs. A single name certificate can cost $0 or even like about $10. Some certificate can cost you up to like $500, okay, because of what they cover and what they provide. In order to understand how the connection, secure connection, and SSL certificate works, we need to quickly understand a few topics. One of them is the symmetric and the asymmetric encryption. This is a very hard topic, and I will have just one slide about that. Now, there are essentially two different kinds of encryptions. The first one is the symmetric one that works with a single shared secret. It's like your password. Now, I'm John. I want to talk to Jane. I want to make sure to talk securely to Jane. What I do is that I encrypt my message with a single key, and that's the encrypted message. And then Jane received the encrypted message. She has the key, and she decrypts the message. Now, the key things to keep in mind here is that the key is shared. It's the single one, okay? And both John and Jane have the key, okay? Of course, the idea is that all the other people don't. Otherwise, that will be meaningless. And that's called the symmetric encryption. The asymmetric encryption is based on public and private cryptography. And the idea is that you have a public key and a private key. All the world has your public key, which can be used by anybody to sign and encrypt a message. Then is delivered to you, and only the owner of the private key can decrypt the message. Okay, so why is that useful? That's useful because I can share my public key with anybody. Okay, so anybody can get my public key anywhere. They can sign a message, and they can send the message through a wire, and they are sure that only myself will be able to decrypt the message. And it's more secure because only as long as I keep the secret key secure my computer or whatever, the message will be secure. So essentially there will be less parties involved into sharing the secret. Now keep in mind that imagine this procedure deployed to a network of 100 computers or 100 people that have to talk to each other. In this encryption model, all the 100 people have to know the secret. So the more people knows the secret, the more you increase the chance that someone will grab the secret and be able to decrypt all the information. Okay. Now HTTPS uses both. Symmetric encryption is less robust, but it's faster. Asymmetric encryption is really slow, but it's a little bit more robust. Okay, so that's the graph of symmetric encryption. How do HTTPS use that? Well, first of all, unfortunately, it's not very a one-click setup yet. That's a very high-level overview of the HTTPS connection. First, everything starts with a TCP connection. I will skip the TCP part. And then the client connects to the browser and say, hey, client, I'm the browser, and I can understand this kind of encryption protocols, and nice to meet you. And the browser responds. The browser responds, the server gets this information, and then from the capabilities of the browser, will send back a response that contains only one specific encryption model, and will say, hey, dear browser, welcome. That's my information. That's the kind of settings I want you to use. So I want you to use this encryption model. I want you to use this and this and this. And that's the certificate. That's the way I can tell you who I am. The client will then get the information, and all this part of communication is handled by the asymmetric encryption. Okay. In this part, we use asymmetric encryption. Now, part of the connection is unencrypted, but at this point, we are using asymmetric encryption to securely share a secret token. And at that point, the secret token that is faster is used to use asymmetric communication each other. And then the rest of the connection is encrypted, and the information is shared using symmetric encryption really quickly on the HTTPS connection. Now, this is called the handshake, and I'm going to skip through that. This is called the handshake, and this is the complex part to understand. What you have to understand is that at this point, the ingredients for you in order to enable HTTPS on your server are a bunch of settings and an SSL certificate, because it's what tells you that you are trusted. So how can you obtain an SSL certificate? You have two different kinds of certificates. You have the self-signed and you have the trusted. That's the main difference. Both provide encryption. The problem is that the self-sign is generated by you, and it doesn't provide trustness. The trusted one, issued by a certification authority, is trusted and provides also authentication on top. The self-sign is generally used for testing, and it's free because you can generate that on your machine. The trusted one is not free generally, and you have to go through a third party, which is called the certification authority, and generally pay for that. The certification authority, as I said, is a third-party company that essentially act as a trusted component and say, hey, I know that you are this person, so here's your certificate that will give you the chance to tell the world that you are who you say you are. The way it works is called the chain of trust. This is a very important topic to understand. So your browsers have a set of what they are called trusted certificates. And these are essentially certificates issued by representing the certificate authorities. Okay? These certificates are, imagine like labels or numbers. They are stored within your browsers. Okay? And there are very limited numbers, like 10 or 15, or whatever the certificate authorities are. These are called root certificates. Now, when a certificate authority issues a certificate to you, so you go to a certification authority and you ask a certificate, the certificate authority will give you a certificate and will guarantee for you, like a lawyer, will tell, hey, that's my guarantee, that's my stamp that tells the certificate was issued by me and I can trust you. Actually, in reality, there are like intermediate certificates, but that's more or less how it works. So I use my trusted certificate to sign another certificate that actually will become trusted by transition. And in fact, when the browser connects to your web server, what will happen is that the browser will check whether the certificate is one of the certificates they trust, they have stored in their code. And if it doesn't, they will check who is the issuer of the certificate. Is the issuer trusted? No. Is there another certificate in the chain? Yes. And that will walk the chain towards the root until they reach one of the trusted certificates. So remember, this is your certificate, the one you buy and the one you will install in your server. And this is one of the trusted ones that is hard-coded in the client. If the chain is by transition verified, then your website will be verified. Now, of course, you can understand now the difference between trusted and untrusted. If the certificate is signed by a trusted authority, then the whole chain will be trusted. If I use a self-signed certificate root, so something I create on my machine, that won't be trusted. Because the final certificate in the chain is not in the collection of the trusted certificates within the browser. Well, here's a screenshot where you can walk from the original certificate through the chain until you can find a trusted certificate. How do you generate a certificate? Well, quite simple. First of all, you have to create a public-private key pair. And we say that we use public asymmetric encryption. So we have to generate an RSA public key pair. That RSA is the most common one, but you can also use other different kind of public keys. That's the command, by the way. So first of all, you create the cryptography definition of yourself, your public-private key. Then you generate a request. It's like when you go to a restaurant and you order, I don't know, a pizza. Okay, so the waiter comes to you, you make an order. And the CSR is your order. In the order, you enter all the certificate information. Which domain you want the certificate to be valid for, who you are, what's your company, where the company is located, the state, the country, the email of the owner of the certificate, and so on. And once you get the order, you sign the order with your private key. And you deliver, well, in the case of the of the self-sign, you sign the certificate by generating a certificate with a CSR. Okay, so what you get is the final certificate that contains all the information within the CSR. And the certificate is signed and includes your public key. So your public key will be distributed to the clients as part of the certificate. And that's a self-signed certificate. All the commands are here, and there's also a nice tutorial if you want to try to generate a self-signed certificate locally. But what if you want to have a trusted website? Well, if you want to have a trusted website, the final step is kind of complicated. The CSR has to be sent to a certification authority. Now remember, the CSR has all the information required to issue the certificate. Then the certificate will detect the certificate type from the CSR, will validate your request, so we'll follow up with you to make sure that you are who you are, and then we'll deliver the certificate to you. I'm going to skip through that. So to quickly recap, at the end of the signing process, what you will have is a CSR file, which is your order. You will have a certificate, which is the shell of all the connection information, the domain, and so on. You will have a private key that you won't have to distribute. You will have to keep secret because the public one will be inside the certificate, and that's what you will deliver to the audience. And optionally, you will have a list of intermediate certificates that will help the browser to trust your final certificate. And then, so what do you do with that? You have to deploy that. And the way you serve is by installing the certificate on your server and finally configuring the protocol. This is a typical example of a configuration. What I want to show you is this part here. Here's where you tell the server to use the server and the private key. The server will get information and will encrypt the communication using the configuration inside the certificate. I will go quickly through that because it's highly technical. And because if you want to understand the details of the configuration for your server, what you can use is one of these websites that will help you to generate the configuration for your server, and you can actually use them and copy them into your server. Better if you try to investigate what all these configurations are. Now, there are actually services where you can skip the details of the low-level configuration and cipher configuration. And one of them is, for example, Heroku. Once you have your certificate in your key file, you just call specific API commands, and they will provision all the infrastructure for you. Okay, so that's a very easy way to simplify the adoption of HTTPS. Another one, very interesting project, is Caddy. Caddy is a web server that has built in the ability to go to a certification authority, connect, validate your request, fetch the certificate, and serve HTTPS from within the browser immediately. From within the connection immediately. So the beauty of that is that the whole things about provisioning HTTPS is built in within the web server. I encourage you to have a look at how Caddy works. This is a very interesting website where you can verify whether all your setup or HTTPS setup is working fine. This is a validator for your HTTPS connection. Now, there are a lot of things that can go wrong within your HTTPS connection. Specifically, you may be using a very old version of the protocol, insecure version of the protocol, or you may be using bad cipher suite. So this tool will help you to better understand if your SSL connection is properly configured. The last step I want to talk about, which is a little bit more soft, is how you properly serve HTTPS. Now, this is a little bit more soft, and we are reaching the end of the presentation because it's mostly about feature of HTTP, okay? So just enabling HTTPS on your server is not enough. First of all, cookies has to be marked as secure. Otherwise, you can serve cookies that will be used downgraded to an HTTP connection. And the way you need to make sure to serve cookies is by setting the secure flag. So if you turn on HTTPS today, make sure you also properly flag your cookies as secure. Otherwise, HTTP connection will be able to use cookies created by an HTTPS connection by effectively being able to access protected information from an unprotected connection. Okay, that's really important from a developer point of view. Another very common error is what's called mixed content security. So you're serving HTTP assets like linking to an image or to a JavaScript file from hosted on a HTTP server from an HTTPS connection. Now, there's a very interesting, as you can see here, the browser will show you HTTPS, but there will be no padlock. And here's the example, HTTPS here from an HTTPS. Now, what's interesting is that Chrome, the latest version of Chrome, has a security tab inside the developer tools. I don't know if you've ever seen that. That shows a bunch of information about your HTTPS connection. So you can click on that and you can actually debug why your connection is not properly secure. Other things you have to keep in mind is that there's a bunch of headers that can help you to make sure that your connection can be downgraded to HTTP. One of them is the HSTS header. I don't really have time to talk about that today, and it's probably not even good things to talk about today given the time and everything. But I will be happy to discuss about that if you have specific questions. So there's a way for you to tell the browser, I don't want my website to be never requested by HTTP, only HTTPS. And that's the HSTS header. By the way, there's all references in my slides. And public key pinning is a way to say, I just want my connection to use that specific certificate. And if the browser will use another certificate, essentially they will refuse to connect to your website. So it's an extra security measure. A very interesting website, you should check it out, is securityheaders.io that will validate your HTTPS setup, and it will tell you if you forget some important configuration. A very interesting project is Let's Encrypt. It's a new certification authority that will issue certain kind of certificates for free. It's a completely open source. It's written in Go, which is a very cool programming language. And that will completely change the way HTTPS will be done in the next few years. And a very interesting book about HTTPS, very highly technical, but with a bunch of interesting information, is this specific one that goes through all the details, high-level and low-level details of HTTPS. And sorry for being a very technical talk. I know it was not really appropriate for 5:20 p.m., but thank you for being here, and I will be more than happy if you have specific questions or like specific dubs to explain and talk about them to you. That's my website. That's my Twitter handler. If you have questions, feel free to ask them. And thanks for being here. And you can now go and grab your beer, given that I think that's your main goal right now.